Hi everyone, today's lesson we are continuing our journey to learn about functions and whether or not they are linear or non-linear. So how do you identify functions with equations or graphs? So we're going to talk about first, how do you know if something is linear or non-linear? What will it do when it's in an equation? So here is your first example, and we're always looking for y equals mx plus b. That will tell us if something is linear or non-linear. So example A says y equals 4 groups of x minus 1. Our job is to determine, is this linear or non-linear? So we're going to start first by using the distributive model or the distributive property. And so we're going to say we have 4 times x, which is 4x, and 4 times a negative 1, which is negative 4. So this is y equals 4x minus 4. So does it fit into a y equals mx plus b? Let's look. Y equals mx plus b. It does. So because this all matches up, and this could be plus negative 4, right? Because all of this matches up, this is a linear function because it creates an equation that is a linear equation. It will have a constant rate of change, so that's why we know. It has a constant rate of change, which is 4 over 1, or a slope of 4. So that creates a linear function. All right, let's do another example and look at this equation. I have y equals 4 over x. 4 over x. All right, so let's look at this. So that's our first question that we would ask ourselves. Can we fit this into y equals mx plus b? Let's look at it. Y equals, I still don't have anything. If I were to substitute 1 in here, let's say I said that x equals 1, I would just have y equals 4. That is not a y equals mx plus b. It is missing something. So because it's missing something here, it doesn't have a slope-intercept. So this one is not a function. This one is non-linear. So this one is non-linear. And that is because it doesn't have a constant rate of change. You cannot write it as a y equals mx plus b. So nonlinear doesn't have a constant rate of change. So this example B, nonlinear. This one is linear because it equals y equals mx plus b. You can fit the pieces into the equation. Okay, let's check out another example here. Sorry, my math chips were in the way there. All right, do this problem here. (6x plus y equals negative 3). Is this a linear equation? can we make it say y equals mx plus b? Well, let's check this out. I can subtract 6x from this side and subtract 6x from this side. So when I put this into my equation now, it says y equals negative 6x minus 3. Again, we're looking for y equals mx plus b. Y equals m, there's my m, my slope, x minus b, or plus a negative b. This is a linear function. So this one is linear because a constant change, like the slope is constant, it is negative 6 over 1 or negative 6. That means you will go down 6 over 1, down 6 over 1 in between each of the points. All right, and our last example of equations that we're going to do before I give you some try-its, this says, where did it go? Okay, y equals 4x squared. 4x squared. Does this create a linear equation? This one is no. This one is no because this x squared does not help to create a constant rate of change. We don't want x squared. So our rate of change will, these two as they work together, will give us y values that do not give us a straight line. So this does not equal mx plus b. So this one is non-linear, and it's non-linear because x is squared. The rate of change is not constant. Slope, not constant. Okay, so I am going to now turn my page. So if you need to pause, but I'm going to turn the page so that you can do the try-its, okay? All right. So there we go. Okay, just got to get my example here for you. Oh, wrong color. We need the try it color, Missing Wonder. All right, try it. Try it number 1. Try it number 1 looks like this. Y equals 4x over 3. Is this one linear? Don't get tricked on this one. And number 2, y equals 1 minus x squared. Okay, go ahead and solve these. Hit pause if you need help, or if you hit pause if you're needing assistance, okay? So you can do these. I don't know what I'm saying. Oh my gosh, my brain. All right, so let's go ahead and solve this. This problem here, remember that this one can be written as x, right? So this is y equals 4 over 3x. So this problem here, 4/3 x, this one works. So this one is linear. All right. And the last problem, this one here. If we move things around, so if we use the commutative property and we say negative x squared plus 1, this problem here, this one is not linear because this 1 it does say y equals, right? You can put this 1 right here, and that is negative 1x squared plus 1. It's because of this squared right here that it is non-linear. So this one is non-linear because it has x squared. Okay, how are you doing so far in checking for linear versus non-linear in equations? Go ahead and rate yourself there. You can just put your little rating out to the side. Oops, you can't see it. Okay, now we're going to talk about graphs. Okay, so we're going to look at some graphs and we're going to talk about, are these graphs linear or are they non-linear? All right, so example A shows a graph that looks like this. This graph right here does not form a line. So because this doesn't form a line, this one is non-linear. Doesn't form a line. We want a straight line. Okay, this one, example B. Let's look at example B. Example B looks like this. Remember, we also want a straight line that doesn't reuse any of the x values. Okay, so that's super important for us to remember. Okay, on this one, we have a graph, and the line goes this way. Is this one linear or non-linear? Well, this function is linear. It is linear because it forms a straight line. So here you have two examples of linear and non-linear lines. Okay, we're going to now look at an example that looks like this. So this example C shows a graph, and on this one, the line goes like this. Again, this one's non-linear because this is not a line. So this one is non-linear. It is not a line, so it is non-linear. Okay, and example D. Example D you all should know because it's what we've been working with always. This one is linear. It forms a line that doesn't use any x values. Doubled, like extra x values, right? Okay, so now it is your turn to do a try it. So on your try it, so your try it's example number 1, I want to know, is this a function? Is that a function? Okay, and example number 2 wants to know, is this graph a function? So hit pause right now so you don't hear me solving these, and then when you are ready, hit play, come on back, and we will check our work. All right, this example here, this one is non-linear. So this is a non-linear function because, again, it does not form a straight line. It started to make a straight line, but then it curved back down. So this one, non-linear. There is not a constant rate of change. Positive slope, then a negative slope. It's not a constant rate of change. Okay, and this one is linear because it does have a constant rate of change. All right, it is your chance right now to answer your essential question. How can you tell whether something is linear or non-linear? How can you tell linear and non-linear functions in an equation or in a graph? How can you tell? And then put your answer out to the side. And then when you are ready, if you have questions, come on back to the Google Meet, or you can go on to Big Ideas and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.